Merhabalar. Öncelikle herkese hoş geldiniz demek istiyorum. Autodesk Türkiye'de mimari mühendislik ve inşaat sektöründen sorumlu iş geliştirme yöneticisi olarak çalışıyorum. İsmim Şennur Karabayır. Bugün hepimiz çok heyecanlıyız. Türkiye'de ilk defa Autodesk'in üniversite versiyonunu yapıyoruz. Bundan sonraki senelerde de hep birlikte olmayı diliyoruz. Bu salonda gün boyunca akşam üzerine kadar gerek müşterilerimiz, gerekse teknik ekibimizden danışman arkadaşlarımız sizlerle BIM konusunda paylaşımlarda bulunacaklar. BIM'le alakalı bilgisi olan, bu terminolojiyi bilen, kullanan aramızda kimler var acaba? Evet, epey bir çoğunluk durumundayız. BIM konusunda ben çok detaya girmek istemiyorum. Çünkü bugün farklı sektörlerden farklı müşterilerimiz ve danışmanlık ekibimizden arkadaşlarımız farklı disiplinlerle alakalı BIM süreçlerinin nasıl uygulanacağı, müşterilerimiz de kendi firmalarında BIM süreçlerini uygulayarak nasıl faydalar sağladıkları konusunda sizlerle deneyimlerini paylaşıyor olacaklar. BIM bugün sadece mimari, mühendislik ve inşaat sektöründe değil, aynı zamanda işverenler, müteahhitler tarafından da altyapı sektöründe de kullanılan bir süreç durumunda. Çünkü müşterilerimiz şunun farkında, kendilerine zaman, maliyet ve koordinasyon açısından BIM çok ciddi faydalar sağlıyor. Bugün de bu faydalar konusunda size çok detaylı bilgiler veriliyor olacak. Sözü çok fazla uzatmak istemiyorum. Ben sözü teknik ekibimizden danışman arkadaşımız Hany Shabana'ya bırakıyorum. Floor is yours, Hany.
Yeah, thank you. So, good afternoon, ladies and gentlemen. I'm sorry I don't speak Turkish, so I have to speak in English. I hope that my English is clear enough for you. If I'm speaking too fast or you want me to repeat anything, please feel free to stop me. So first to introduce myself, my name is Hany Shabana'nın. I'm a structural engineer by profession. I work for Autodesk in the Middle East. I'm based out of Dubai office, and I'm an AEC technical specialist. AEC stands for Architectural Engineering and Constructions, mainly in the building side. So in today's class, we are going to explore the structural workflow available from Autodesk solutions for structural engineers. So if you are a structural engineer, structural drafter, working either with the concrete structures or the steel structure design and detailing, this class fits for you. So let's continue. So what are we going to look at today? We are going to explore the bidirectional and collaboration structural workflows between the different flavors of Revit. And also we are going to see how you can extend the design model created in Revit structures and send that model to the analysis and design solutions and available from Autodesk cloud services. We'll have a look at the Autodesk 360. In the general session, you have seen that anything that has a logo 360 with it means it's in a cloud solution. Cloud solutions mean that you send your model out to the cloud to run the analysis and keep your machine resources free for other work. Then we'll see how to take that design model and expand that to the fabrication solution, both for concrete and for steel. Today, I'm going to concentrate on the steel side of it because we have acquired a new tool called Advanced Steel, which is for steel structures. Later on today, we have a specific session by a BIM manager that will explore the concrete side and the reinforcement side of it with more of practical solution. At the end, we will have some time for Q&A. If you have any, please feel free to ask. So first, let's go with the structural workflow. This is a typical structural workflow that happens in any project. We want to see what are the solutions available from Autodesk for that. Autodesk introduced Revit or Revit structure as a BIM platform that works throughout the whole design life cycle. So in Revit structure, you build up the physical model, but at the same time, while building your physical model, your analytical model is being created automatically for you. After that, you start adding your loads and prepare the analytical model for analysis and design. At this point, you have two options. The first one is to run the analysis and design using the analysis and design tool, the analysis tool for Autodesk Revit structure, or you can send that to a more robust and complete comprehensive analysis tool, which is Robot Structural Analysis Professional. You can do that on your desktop, or you can send that to the cloud and get the results back. After that comes the detailing stage. After you finalize you have the design, you have your analytical model, then you can import your analysis design back to Revit for documentation. Your model is ready to go for the detailing and fabrication. For that, you have three solutions out from Autodesk. First is AutoCAD structural detailing. I assume everyone here knows AutoCAD structural detailing. Who is using AutoCAD structural detailing currently? Few? More people coming? Okay, great. So you know that. AutoCAD structural detailing is a special edition of AutoCAD specifically for the structural engineers. But it's not BIM. It's the link between the CAD workflow and the BIM workflow. If you want to continue with BIM, now Autodesk introduces Autodesk Advanced Steel, which is for steel structures, and Autodesk Advanced Concrete, which is for concrete and reinforcement structural workflow. And both are BIM solutions. Or you can use a partner solutions if you would like to. Just to see kind of the interoperability or how these different solutions talk to each other, because it's very important to streamline the data flow from one application to another. This is the whole idea about BIM. BIM, building information modeling, is about information flowing between different applications seamlessly. So, in Revit, you know that the three flavors of Revit, architectural, structural, and MEP, you can have a direct exchange between them. You can read the RVT files in either applications. And we'll have a live demo for that showing how the structural engineer can use the architectural model to start his design. After that, the analysis stage comes where you have three options: robot structural analysis, this is a desktop application, or you can send it to robot structural 360. This is the same capabilities of robot structure but on the cloud, or the final one, which is the structural analysis for Autodesk Revit. Actually, it should come at the beginning as a preliminary analysis to understand the behavior of your structure. And finally, the shop drawing and fabrication, where Autodesk, AutoCAD structural detailing, advanced steel, advanced concrete come. Just if you take some time here to look at the numbers on each of these collaboration methods. So you have a direct collaboration, or as I like to call it, horizontal collaboration between Revit, where you can read directly the RVT files, or using the Revit extension, which is number 4, so you can send the models between Revit, exchange the models between Revit, robot structural, or advanced concrete bi-directional way. Don't worry about that, just to give you an idea about the workflow. We'll see that live on demonstration, how you can exchange these models together. So let's start directly with the collaboration. So what's really nice about having Revit and working in a collaborative environment is that structural engineers doesn't have to live in a silo where he needs to talk to architects and with every change the architect made, he doesn't know what has happened in the model, and they need to communicate that in a manual way. So what I'm going to present right now, I'm going to open a Revit template for you and then import the architectural model and just copy and monitor the important elements for the structural engineers in his model, so that if any change happen in the architect model, the structural engineer will be able to detect that automatically and take necessary action for that. So let's go ahead and just start with a new template. I'll start with the structural template. Now I have my empty project. If I just go to the east view, so I'm deleting here my level, so I have an empty model. Going to the insert, let me get my architectural model. So here, I get my architectural model. Usually I use the origin to origin. This is the best way, by the way. Don't use the center to center. It's unpredictable behavior. Okay, close these links. So now I have my architectural model as a link in my file. This is direct integration. I'm reading the RVT file. What's really important here is that I need to copy the important elements to me. So I'm using the copy monitor tool available under Collaborate tab, select my link, then I need to copy. First thing to start with is the grids and levels. These are the most important things. You have a little thing that you have to do here first at the option. These are the 5 types of elements that can be copied and monitored: levels, grids, columns, walls, and floors. Structural engineers will not need anything else from the architectural model other than these 5 elements. So what you have here is a mapping tool. It gives you the ability to control when you copy monitor, how do you want to copy that. So for example, I have here's a type in the original file. How do you want to copy that into my structural file? So I would say here, choose just copy original type. I don't want to change anything. When I talk about levels, usually the architect will use the finished floor level, but me or us as structural engineers, we want to use our top of concrete level, for example. So here I have the capability to make it minus 10 centimeters or 100 millimeters down of the architectural finished floor level. And then I can give a prefix, so I give it here top of concrete underscore, so whenever the levels will be copied, it will have the initial top of concrete to differentiate it from the architectural levels, so I don't get confused. Next thing, I'm going to grid, so now here I'm fine with the mapping. I will continue with the grids, and I will give it just a prefix S for differentiation. I'll keep the columns right now as it is. I press OK, then I go to copy, select multiple. I will do this window selection and use this powerful filter tool just to filter only the elements I have. So I don't have to pick only elements one by one. I just press select grids and levels, press OK, and finish. And Revit will automatically take care of copying that. If we just move a little bit here to some of our levels, we will notice here that these are our levels. I have a top concrete first, and I have up there the architectural levels. If I select that floor, you will notice here this little symbol, this heart tracking symbol, which showing me that this level is being monitored by the architectural model. Or in my model, I'm monitoring that level actually. So if any change happened to that level, I will be able to see it. The same happens here. I have the structural file. I have the structural grids comes to me. If I actually open the, at this stage, I need to create my views. So it's not a problem. Let me hit just finish, go to view, create structural planes for the first, ground, and roof. Okay, and then I have my structural planes available for me. If I look here, just let me hide the link, Revit link, to show you something. Then I have my models. You notice that I have my grids only in one direction because I did that only from the east. So simply to complete that, I'm going to the north, the other direction, perpendicular to that. And I'm going to repeat that again, collaborate, and, collaborate tab, copy monitor, select the link. No, just need to press it again. Here, select the link, it will be open for me. And this stage, I will do copy the rest of the grids on the other direction and also the structural column. Before I do that, I'm going to the columns option. Here you have the architectural column as appears in the architectural file, and you have the mapping of it. So it depends. How do you want to copy that? You can keep it as concrete. In my example, I'm just copying it to universal column, steel columns instead of concrete, because I am the structural engineer. I have the control over that. I don't have to copy exactly what the architect is proposing for me. It's just a proposal. And here, for that column, I'll adjust that column because I know that it will be concrete. I'll copy it as concrete. So I have control over that. You have a little tick box here that's very useful. It's asking you to split the column by level. So if an architect create a column from the ground till the 5th floor directly as one column, you know as a structural engineer that you need to split that column into different levels. So this option is very useful. You can just pick it and keep it in your system. And then I'll choose the copy again, select my file, filter it. At this time, I select the columns and the grids, apply OK, finish. So finish now. If I go back to my top first, I have my columns, and also I have my grids completed. So now I have my structural model and I have my grids, and both of them are monitored from the architectural model. If I just want to show you something here, just to show you the split that happened. So I'm going to hide this element. If I zoom in to any of that column, you'll notice that my columns are both monitored, but also they are split at my level. So at this stage, let me save my project and do some changes. So AUX structural, save my model, and I'm going to simulate that an architect has done some changes to his model. So if I open the architectural model, and let's do a couple of changes to see how the structural engineer will be able to monitor that without the need for him to be communicated manually. So I'm going to my ground floor. So now I'm in the native architectural model. Let me assume that for some reason the architect decided to just move this grid, let me maybe in this direction, by 500 centimeters, sorry. So 50 centimeters actually. So you notice here that also my columns has been moved with that because I decided that my columns will move with the grids. Let me also change a level to show you just another example. So in the elevation, if I go to the first floor, let's make this 3,100. Maybe the architect decided to change the finish floor material, and then he needs more thickness for that. So once I do that, I have a couple of changes. Save my model, and then directly I'll go to the structural model to see how that happens. Okay, let me open this is my AUX structural model. So here a message comes automatically telling me that an instant link needs to be coordinated review. So I need to do a coordination review to check what are the latest changes happened to my model. So in the Collaborate tab, go to Coordination Review, select the link. Let me open the south link. Just do it again, select the link. And automatic report comes to me telling what happens to my model. So I have here the grids. So I have grid has been moved. If I select the grid and press show, it's telling me that, okay. It's highlighting the grid for me automatically. So it's showing me that the grid S3 has been moved. What do I want to do? Okay, because it's a grid, I have here a list of actions. So I can postpone, I can reject, or I can accept the difference between them, and finally I can modify it. So in this case, I will modify it. You can add a comment if you want. Okay, let's say accept as per architectural model. Okay, then let's explore the other changes happened. So here I have the levels. If I select it again and press show, it's going to tell me, okay, now I have a change in level here. Because I'm a structural engineer, this change in floor level will not affect my work, so I'll just select the option here to accept difference. I don't want to change that. It's not a problem for me. This is an architectural thing. Next to the structural columns, I have here a list of change in the place, so I'm going to accept all of these changes. Move the instance, hit OK, and automatically, if I go to my ground floor, my S3 level has been changed, updated, and also my structural columns moved along with it as well. If you just do a measurement here, so now it's 2 meters instead of that. So that concludes actually the copy monitor tool and how the structural engineers can start working in terms of the architectural model without the fear of losing the communication or something change in the architectural model, and then you are working with something else in your structural model. So that was just a recording of it. Next, we'll see the integrated of structural analysis. We said that while building up the model, you are actually creating the analytical model, because Revit is doing that for you. But the most fear of any structural engineers have said, okay, I have the physical model, but my analytical model might need to be modified in a different way to represent my design intent. An example for that, if I have 2 structural walls, retaining walls with 2 different thickness. Now, if I work with the concept of the analytical model, I have a center line. When I work in analysis, I use the center line of the walls. But now, if I have 2 different thickness, walls coming on top of each other, now I have these 2 centers are not matching. So the first question comes, can I modify my analytical model without affecting my physical model? And the answer is yes. Here I just, because we don't have enough time, I have created 3 samples and can take a snapshot. The first one is 2 walls with different thickness. So you can see that the analytical model represented in blue or cyan actually comes together regardless of the wall thickness. The second thing, if I have a 2 intersecting wall with an edge, that edge is not structural edge, you can modify that. And the last one is multiple walls with beams and the column. You can see here how flexible is the analytical model in Revit. You can control it to reflect your design intent without the fear to change in the physical model. So if your model is ready, once the analytical model is ready for analysis, you can use a couple of solutions that Autodesk provides for structural engineers. The first one was introduced first in the 2014 version of Revit Structure. It's called Structural Analysis and Code Checking Toolkit. This tool, along with the cloud service, allows structural engineers to run a static analysis of their structural design on the cloud and import the results back on Revit. It gives the structural engineers the confidence about the proposed sections, and that to make sure that your structure will carry out the loads applied to it. The second option would be to run a more robust and complete analysis using an advanced tool called robot structural analysis, where you can run seismic load, you can run a time history load, and all types of loads available for you. So here we have two possible workflows. The first workflow is actually to start in Revit structure with the physical model, then the analytical model will be automatically created where you can modify your analytical model to reflect your design intent, add the loads and boundary conditions and load combinations inside Revit itself, and then send the model to the cloud to run your analysis. Again, as I mentioned, this is only an early structural design and analysis. It's only static. It happens on the cloud, and then you import the results back into Revit for documentation and comparison. The second option you have is a detailed and comprehensive structural analysis using Autodesk robot structural analysis. Again, you start the model in Revit, so it is the same model. So the same model can be sent at an early stage to the cloud to run a static analysis, and later on during the design, you can run a more robust and comprehensive structural analysis using robot structural analysis. You can do that on the desktop, or you can do that on the cloud using the Simulation 360 tool. So right now, you might ask yourself, now you are talking about two different cloud services that are available. What are the differences between them? This matrix here shows us what are the real differences between the structural analysis for Revit structure and the comprehensive one using robot structural analysis 360 simulation. The first one, as we said, in the type of the analysis is static. The second one is more robust. You can run a time history analysis, seismic analysis. You can apply wind load and do all these kind of analysis. Next thing is the result storage. In case of Revit, you can save this storage on the cloud. You can create a complete report about the design and the analysis results and produce that report in HTML format for sharing. In the second way, you cannot actually do that. It's not available to be saved on the cloud. So results has to be imported into your desktop, and then you continue with your design and optimization. Run multiple analyses at the same time in both solutions. Yes, you can modify the model. You can send different design iterations to the cloud at the same time while leaving your machine free. And I have a real here, good instance that I can remember. While doing my master's degree back in 2007, I had to buy the Quad 4 processor in order to run multiple analyses at the same time. It took me 2 months only to complete the different iterations that I have to do. Imagine if I had this capability at this time, I would have done it in a maximum week, because I sent an infinite number of iterations to the cloud without relying on the capability of my machine. So you don't really have to rely on the capabilities of your machine. You can send it to the cloud, and as we saw in the morning, you have a very powerful computing power on the cloud. Then the installation, if you're using the structural analysis for Autodesk Revit, then it's actually using Revit. It works on top of Revit. You don't have to install a separate software. But for robot structural analysis, it's a standalone. You need to have robot structural analysis, which comes as part of Autodesk Building Design Suite Premium and Ultimate version. And finally, both of them are using the robot structural analysis. So either you run the analysis in each of them as a static way, you should get the exact same results. After you run this analysis, then you have the chance to import your results back into Revit. This is very powerful because, as I said before, you can run multiple design iterations. You can have different designs, then import them back into Revit for comparison. So I have 2 different designs. You can optimize your work. Even if you are using a third-party application, you can import these results back into the results manager and do your comparison. And finally, if you want to present that in Revit structure itself, it's very powerful. You can represent the deformation, you can represent the heat map, you can represent the internal forces, reactions, either for the full structure or for only selected elements in the model. And this is really powerful. Then you can include that in your design documentation and send it for approval or send it for your contractors or whatever you want, maybe as a part of the approval process. So let's see now how this is actually happening. Now I'm in my Revit structure. This is my physical model. I go to my toolkit, and simply here, by the way, you need to have an active subscription in order to access your cloud services. So once I do that, my model is being sent. First of all, Revit will check the integrity of my model, and if it finds any discrepancies, it will stop you and will say, There is something wrong. You have to check here. So in my case, I have two errors happen in my model. First of all, I forgot to assign structural material to my floors, which is vital for my structural analysis. So I will have to assign structural material, definitely. So go to Revit structure again, select the material and assign whatever material I want. And make sure that the mechanical information is available and assigned for that material. So here I'm assigned a concrete material for my floor slabs. So here my concrete, I have my physical information, okay, and the mechanical properties are identified here indeed. The second thing is that if you have any problems, if you have structural nodes that are not well connected together, you will get a wrong information. Probably you'll get a failure in your structure. To do that, Revit in 2014 actually introduced a couple of filters available in Revit structure to show you the unconnected nodes like these. And there are couple of them here. They are under filters. They are out of the box. You can just activate them and give it a color. For example, give the unconnected nodes, give it a color, a red color. So present that in color, in red color. Once you press OK, then you have a visual report. So I have two unconnected nodes here. I can directly go and align them and make sure that my analytical model is correct. Again, for that column here, maybe this one doesn't appear in red because simply Revit automatically has created a rigid link between these two nodes. That's why it didn't appear in red. But to make it correct, I will connect them directly. So once I'm fine with that, hit OK and send my model again to the cloud for analysis. Of course, before I do that, I have identified the loads and load combinations, but just for the sake of time, I'm just doing that automatically. So here, my model will pass the different stages of checks, and it will be sent automatically. So here, my model is being sent to the cloud. It's asking me just to give it a name and how I want to save it, and then it will be sent. At this moment, my Revit is free. The model has been sent to the cloud, and I'm tracking the progress of my analysis. I don't have to worry. I don't have to wait until the analysis is done. The model is on the cloud, and right now I can proceed with my design. As a second iteration, I'm going to use the same model to send it to robot structural analysis for more advanced analysis. So I'm using the tools. You can see automatically that once you hit the link send to robot structural analysis, the model will automatically go to robot structural analysis and it will open for you. It's exactly the same model. So imagine here how much time you saved by sending the same physical model and analytical model in Revit to robot structural analysis. I don't have to recreate everything. I don't have to reconnect everything. And more importantly, these two models are linked together. So what I'm doing currently here, you can see that also the loads identified in Revit are transferred along with it to robot structural analysis. So I have different loads. I have identified lateral loads, live loads, and dead loads as well. So at this stage, just I'm identifying my stores. This for the seismic analysis later, as you'll see. Then directly, I'm going to create the mesh analysis for the mesh for my floors. So we have a variety of options here to create the mesh. You can make it a simple rectangular mesh, or you can make it more complicated as per your design shape. Of course, here, because I have just rectangular slabs, it's very easy to use just the basic one, and it will give me an accurate results. What I'm doing right now, I'm just identifying manually my load combinations. I can do that on robot structural analysis, so I'm just showing you the different options you have. I don't have to use that. I have an automatic load combination option where I can just select the single load combinations, and robot structural analysis will do that for us automatically. But as structural engineers, we usually like to feel that we are in control of our solution. We don't just need to use the out-of-the-box tools without understanding what's happening behind. If we don't trust the tool, then probably you'll not use it. So what I'm showing here is that you can control everything is happening. Whatever automation you have in robot structural analysis or even in Revit, you have the control to do it manually. You have control to change the parameters behind that. So once doing that, maybe I've just missed part here. is that I'm showing you on robot structural analysis, you have two options, either to run the analysis on your machine or send it to the cloud. So I have selected to run that, to send that to the cloud, and I have done my first iteration. So far, I have two analysis iterations running on the cloud at the same time, and I'm still using my machine. I'm not wasting my time. I'm not wasting my machine resources on running only a single analysis. I have two running, and I'm creating another one right now. Currently, I'm doing the seismic analysis loads automatically as per the Eurocode. And right now, I think I'm just gonna, now I'm saving my model as a second iteration just to show you the different analysis. I don't have to do that, but if you notice here, it's showing you cloud or, calculation. It shows you calculation. So once the status changes to calculating the results, it means that my model has been sent to the cloud and I don't have to worry about the physical model itself anymore. At this point, I'm gonna save my model as a third iteration. So these are the two iterations I have on the cloud currently, coming from robot structural analysis. I have an extra one running for Revit. This is the static analysis that's running on the cloud right now. The final step I'm going to do here, I'm going to create an automatic load combination to show you how robot can help you in saving the time that you might spend in creating all these manual combinations. So first thing, I'm going to go ahead and just delete the manual combinations. I have created them. I've created here 4 load combinations manually. Delete these load combinations and create a new ones automatically out of robot structure. So directly here, select what I need to do. So I have the ultimate limit load casing, the serviceability load casing, and just hit the analysis. And now I have 3 robot structural analysis running on the cloud and 1 from Revit. 4 different models running at the same time, not wasting my machine resources, not wasting my time. I don't have to wait every time a machine is running analysis until it finishes and get me back the results. Also, you can track, actually in the window tray, you can track the progress of your structural analysis so that you can make a more decision when you're going to explore your structural results. So once it's done, I'm just saving the model, just to import the analysis, so I'm just keeping track of my progress. And directly right now, I'm showing the results. At this moment, I'm still in robot structural analysis. I'm viewing my results. You can view it in a heat map, or you can view reactions. You have full control over that. So here, my heat map representing my internal forces imported from the cloud. Just let's save the time. Let's move it a little bit. So currently, you can also run some design integration in robot structural analysis itself. This is for reinforcement. I'm using that automatically to get my proposed reinforcement areas in robot. Just doing the analysis right now, calculate, and then I have a complete sheet with the proposed elements and proposed reinforcement, both top and bottom. The next stage, just directly go to go back to Revit structure and import these results back to my model. So explore and document results in Revit. Now I'm in the Revit environment again. I will go to the results manager. First, I have a look at the first static case, and I'm going to import these results back to Revit structure. So as I said before, these analysis can be saved on the cloud. You can produce a report out of that, a complete report in HTML format showing you what's happening, what are the load cases has been used, and what are the internal forces in each and every element in your structure. Currently, this is on the cloud, but I'm going to import these results back to my Revit for documentation. So I'm saving this to my desktop application for documentation. And these results will be saved within the RVT file. It's not an external file. So if I have a single file for my project containing all my results for the analysis for all different cases. Just taking some time. This here I'm showing you that even you can download the analysis as a robot file and save it for your future tracking. So go to the results manager. Then you can see here that I'm currently reading my results from the cloud. I can download that and start exploring them. So just for the sake of time, go to the Result Explorer. Just now it's reading the first load case I have. So I can present the moment in any direction, internal forces, even the reinforcement area, top and bottom, can be represented. You can see here that now you are in Revit environment. You can take that to your design sheets and keep it. So very powerful, very dynamic. I didn't have to create a couple of models. I didn't have to waste my time waiting for the analysis tool to finish the analysis. I send that to the cloud, imported results back, and I'm ready to go. What I'm doing currently, I'm just downloading the results from the cloud, so I'm saving it internally in my model. What I'm going to do next is just to import the results of robot structural analysis again. So I have, using the same plugin, I'm taking that results from robot to Revit. So here I'm updating the model, just I'm running to show you, okay, now you can see that in my results manager, I have 3 different scenarios that I have run. Also, the load combination created on robot will be imported back to Revit for your information. So you have full access to whatever happened in the analysis, whatever parameters you set up to run your analysis will be saved in Revit. What's happening here, because I imported these load combinations, it's telling me my Revit analytical model is outdated. Because in Revit, I have created only the single load cases, but I haven't created any load combination. So whenever I updated my model, it will show me that my analysis, my current results from the analysis, even the static one that I have run using Revit, is outdated. Again, I'm just showing you that the different capabilities you can use here. This is very interesting usually for structural engineers, where you show the deformation of your building. Usually you couldn't do that before unless we are running an analysis and design tool like robot structural analysis, or even ANSYS or ETABS or SAB. Right now you can see that in Revit and document why you have made these decisions in Revit and what needs to be done to satisfy your design. That was all for that one. So what's the payoff? So now we have seen a seamless workflow between the physical model to analytical model, creating the load in Revit, and just export the same model with loads into an analytical and design solution such as robot structural analysis. This comes for you in the building design suite and has a seamless integration between Revit. But if you are using any third-party analysis software such as ETABS or SAP 2000, you can still use the same analytical model, send it with the loads, and import the analysis information and results back to Revit for documentation. Also, you can see here, you can conduct an advanced analysis, seamless connection between the design and the analysis, and more importantly is to save the time required to duplicate the work. And we have seen at the beginning that we started our modeling from the architectural model. So our structural model and architectural model are currently linked. If any change happens, I will be able to track that change in my structural model and update it to reflect the latest change. The code checking and optimization, this is actually a part of robot structural analysis, but why I am presenting it here? Because we have seen the seamless integration between them. It's bi-directional. Means if I did change anything in robot, it will be updated in Revit as well. So the main challenge, the main business issue here is to create a seamless workflow between the designer and the engineers and keep them working on the same page. So just a quick to represent what's happening, what's the workflow proposed. After you create the analytical model, transfer it to robot structural analysis. Either you will do a concrete design or steel design. Robot structural analysis supports 70 different design and analysis codes available all over the world. You can optimize your design, get the most accurate sectioning and optimize the use of them, and then import them back to Revit model and update your structure, the physical model, for documentation. What's the payoff? So first of all, you are making the code design check as part of your BIM workflow, Again, BIM is building information modeling. Here is the information, the I, which is the most important item. Information transferring from one solution to another in a seamless way without the need to waste your time, and recreating this information and entering it onto different design tools and applications, and make sure that everyone has the same up-to-date information at the same time. Now we reach the detailing part. And Revit structure, actually, it provides you with a variety of tools to create a complete documentation, where you have for concrete, you can create your physical model after you update your design, after you update the physical model from the analysis and design tool. You have now the capability to represent the reinforcement area that came from robot structural analysis into 3D reinforcement in order to produce shop drawings. Run the design coordination to make sure that if you have a heavy reinforcement in your building, they will come together correctly and they can fit in the site correctly, and to produce an accurate shop drawings instead of just breaking the link between the BIM workflow and send that to CAD, and then you have two separate workflows. If you update the model at any time, then the shop drawings are outdated. In the BIM workflow, everything is connected. Same happens for precast. Just want to emphasize here that Revit precast elements or families are designed specifically to fit the precast design. They host the embeds, they host the reinforcement in the same way that a precaster would like to see it. And finally, for steel structures. When you start in Revit, Revit is not really designed to create a shop drawings for the steel structures. The concept is different. Steel fabricators and detailers usually don't use Revit for do that because it's time consuming. Because of that, Autodesk in 2013, actually late in 2013, acquired a product called Advanced Steel. Advanced Steel is a BIM tool available for steel fabricators to automatically produce the connections and create a CNC information for fabrication. Right now, we'll just have a quick look on that Advanced Steel solution. So what's Advanced Steel? Advanced Steel is the BIM tool available for steel structures, detailing, and fabrication. Using this powerful tool, you can automatically produce shop drawings. You can apply the most complex connections automatically and intelligently. If the physical member itself change, the connection will adapt itself to reflect that change. You can produce automatic shop drawings. When I say shop drawings here, I mean a single part, assembly parts, list of bolts and welds, the cut list with graphical representation on the sheet on how this part will be cut. You can also produce automatic bill of material, list of material for list of bolts automatically. You can run the clash detection, and all that happens while integrating the physical model, utilizing the physical model created in Revit, send that to Advanced Steel without the need to rebuild the model again. So what Advanced Steel really fits for? It really fits for any type of steel structures. It can be commercial, residential, plant design, or even a theater. So it's not limited to any type of steel structures, even miscellaneous structures can be used for. I'm really proud of these two references. These are in Abu Dhabi. If any one of you have visited Abu Dhabi before, you can find these. This is called the Capital Gate. This is the most inclined building in the world. Using advanced steel, Wagner Bureau was able to create a component, an intelligent component for the facade, which, as you can see, has double curvature to automatically adapt for the building and to produce the shop drawings required for that. And also, the Marina Hotel in Abu Dhabi, all this shed facade has been modeled in advanced steel. So the solution is well known in our market here, and people are knowing them. These are simple structures that also can fit within it, so you can know that either you are using a very complex project or working on a very simple structure. You have tools that helps you to model the railings and the stairs, which is the most complex part usually that any designer or a drafter actually hate to model, especially the curved stairs, because it's really complex and has some very specific details that need to be done for these stairs. All these type of projects can be automated automatically. So let's quickly have a look here at the integration between Revit and Advanced Steel. Now I'm in the Revit environment. I'm just checking my column. So just I'm showing here that I have this column section. I don't need to do any manual mapping between Revit and Advanced Steel. Simply just identify my sections, use the add-in specifically for this integration, I have the export, import, and synchronize. So either I started my model in Revit, or if I receive my structural steel part from a third party or a fabricator, I can import that automatically to Revit to have a complete integrated model together. So simply send the model, save that, and it will be opened automatically in Advanced Steel. Advanced Steel, as you can see, works on top of AutoCAD. So you don't have to really spend a lot of time learning the software, learning the tool. The same commands you know in AutoCAD is applicable for Advanced Steel, but with more advanced and intelligent connections that can be applied to our structure. Here I've imported my structural model. I have different representation, as you can see, the same as you use the wire frame, the shaded frame, you have a realistic view. Select the same column. See, automatically I don't have to do any mapping. Directly it comes, and I have the same cross-section comes, but with all the dynamic and properties behind the section identified. Let's use our connection vault here. I'll talk about it in a second. Simply choose two elements, and the connection will be applied automatically. Any parameter in this connection, it's parametric and intelligent. Parametric means I have a full control of all the parameters, like the number of bolts, the edge space, the hole size I want to use, automatically controlled here. So this is what you're seeing now. Actually, I don't think you're seeing the bolts correctly, but it's fine. So we have seen it right now. Whatever you create in Advanced Steel can update the Revit model as well. I don't really like that workflow to take the model back to Revit because of the file size, because in the actual workflow is once I finish my structural design in Revit, I should take that to Advanced Steel and then move to Navisworks, which is the right tool for integrating or aggregating all models together in a really lightweight and run a robust clash detection and create a clash detection report. But if you want to update your Revit file, you can do that, as I mentioned before. So this is the connection vault available in Advanced Steel. They have a robust combination of steel connections, all dynamic and intelligent, and they are all grouped under different categories to make it easier for you to find that. Let's go directly just to see a live demo about that. This is the connection vault available on Advanced Steel. You can see that it's categorized according to for example, a shear connection, a moment connection, base plate, everything is categorized easily. And you don't have to really go and check for every time you want to create connections to go to check all these like hundreds connections. You can create a favorite list as you see here. So most of the steel fabricators that I know, that I worked with, actually use around from 50 to 70 connections, and they don't use the rest. These are their standards, and they can save it as well. As you can see here, I'm applying my parameters. I have a full control of my steel structures over my connection. I apply that, and even I can copy the same intelligent component to the other side. What's really interesting here is that if I updated the physical model, if I change the column size here, due to any reason, these connections will adapt automatically. So this is a level of intelligence that might save you time and make sure that your project is accurate. Either you did that manually, or you did some update in Revit model and you updated the Advanced Steel model, the connections will be updated automatically. So here just I'm applying different types of parameters. You can see how the beams got cut back automatically without manual intervention from me, just identifying the parameters. Here I'm adding some stiffeners, let's get this part, just a few seconds, adding some stiffener to my project. At this moment, what I'm going to do now is I'm going to change the middle column. You can see now I have 4 connections. I'm going to increase the size due to any design changes. Maybe the column section doesn't satisfy my design. Update that model, and automatically my connections will be adapted automatically. And this is the power of BIM in the steel industry. Again, we have a complete range of connections, intelligent connections available for the staircases and miscellaneous steel structures. Ready-to-use templates for shop drawings and GA. These here, just I created some samples of the steel shop drawings and general arrangement drawings that can be produced automatically from Advanced Steel. Of course, any change happen to the model will update the shop drawings, the bill of material, and will also control a highlight over the parts that has been modified as you would expect from a mature BIM solution software, that you have everything centralized with the BIM model. Continuing to CNC files, this is really related to the fabrication shop. When they have the BIM model, they can automatically extract CNC machines in different format in DSTV or DXF to go directly to CNC machines to cut out your part. So if any steel fabricator is sitting with us now, he can understand what I mean exactly by, instead of spending time trying to understand the shop drawings and take the dimension manually and feed them into the machine, you can create, with the push of a button, a CNC file, take it to the fabrication shop to fabricate that automatically. And finally, you have many templates to produce bill of materials automatically out of your BIM model. So you're talking about the number of bolts, the weld preparation, the cut sheets with a graphical representation, as you can see here, of the dimension of these plate sheets. So what's the payoff? Now you are streamlining the physical model you have created at the beginning of your design stage. You have taken that model with you into the analysis and design. You have created analysis in Revit structure in the static way. Then you've done a more robust structural analysis and robust structural analysis. You updated your design, you actually optimize it, and then you take that to the fabrication, detailing and fabrication stage, and finally you produce the CNC machines. And more importantly, you have a multidiscipline clash detection to make sure that your project is coordinated from the early stage. I have done with my presentation. I think I'm on time, just it's 45 minutes. If anyone has any question for me regarding what I have presented, please feel free to ask now. Any questions? Everything's clear so far? So I have to thank you and enjoy your lunch now. Thank you, guys.